What is the sound of true silence? Not the quiet of an empty room or the muffled stillness of a winter snow, but the profound, absolute quiet that exists between the stars. For millennia, we have strained our ears and our instruments towards that immense void, listening for a signal, a whisper, a confirmation that we are not alone in this boundless, silent ocean. We built machines to amplify the faintest cosmic murmurs, charted the sky in wavelengths of light our eyes can never see, and waited patiently for a reply to a question we had not yet fully learned how to ask. But perhaps we were mistaken. Perhaps the universe does not shout. Perhaps it waits for us to venture out beyond our own shores to dip our hand in the interstellar sea before it reveals its deepest secrets. We believed the first reply, if it ever came, would be a grand announcement, an undeniable beacon. We never imagined it might be a fleeting ghost, a celestial phantom that passed in the night, noticed only years after it had vanished forever. We never imagined the message might have already arrived, not in a language of radio waves or mathematics, but in the silent, unnerving language of impossible timing. Our first attempt to truly speak to this void was a voice of gold and copper. Launched into the departing dusk of 1977, the Voyager 1 probe was humanity's most audacious dream, a whisper in a bottle cast into the cosmic ocean. It carried with it the golden record, a time capsule of our world, etched with the sounds of Earth, the cry of a newborn, the call of a whale, the harmonies of Bach, and greetings in 55 languages. It was a message of peace, a portrait of our species, sent on an almost eternal journey to any civilization that might one day find it. For decades, it was our tireless explorer, a robotic prodigy that peeled back the veils of Jupiter and Saturn, revealing worlds of furious storms and ethereal rings beyond our wildest imaginings. It sent us postcards from the edge of our celestial neighborhood, its plutonium heart beating faintly against the cold, its instruments faithfully recording the story of our solar system's outer ramparts. But its primary mission, the grand tour of the gas giants, was always just the prelude. Its true destiny lay beyond. For 35 years, Voyager 1 sailed outward, its speed an almost incomprehensible 70,000 kilometers per hour, yet barely a crawl against the canvas of the galaxy. It journeyed toward a frontier no human-made object had ever touched, a boundary not of space but of influence. This is the heliosphere, the colossal magnetic bubble inflated by our own sunday. Everything you have ever known, every planet, every asteroid, every human life has existed entirely within this protective cocoon. It is a sanctuary, a region carved out of the galaxy, where the sun's own wind, the solar wind, reigns supreme. This constant stream of charged particles pushes back against the far more ancient, more mysterious medium that fills the space between the stars, the interstellar wind. For all of human history, we have been creatures of the sun's domain, shielded by its magnetic breath from the harsher realities of the galaxy beyond. We had theories about what lay on the other side. We had models, but we had never been there. We had never tasted the water. Then, in the summer of 2012, something began to change. The data trickling back to Earth across 19 billion kilometers of emptiness started to tell a new story, a story of a shore being reached. Voyager's instruments, designed for the environments of Jupiter and Saturn, were now our only senses on this alien frontier. The low-energy charged particle instrument began to register a dramatic, unmistakable decline. The familiar particles of the solar wind, the very breath of our star that had accompanied Voyager on its entire journey, were suddenly vanishing as if a great wind had abruptly died down. Simultaneously, another instrument, the cosmic ray subsystem, reported a startling surge. Galactic cosmic rays, high-energy particles forged in the hearts of distant exploded stars, were flooding in. These were the raw, unfiltered radiation of the galaxy, the very particles our heliosphere had protected us from for eons. The shield was failing, or rather Voyager was leaving the shield behind. The scientists at NASA's Jet Propulsion Laboratory watched their screens in stunned reverence. They were witnessing in near real time the crossing of a lifetime. The data was a travelogue from the precipice of infinity. Imagine yourself on that probe. For 35 years you've sailed a familiar sea, the currents always flowing from behind, pushing you outward. The very texture of space has been dictated by one star, your star. Now the current stops. The water grows still, And then a new current, colder, stronger, and utterly alien, begins to press against you from the front. The light changes, the pressure changes. The very nature of reality shifts. On August 25, 2012, the numbers solidified into an inescapable truth. Voyager 1 had done it. It had punched through the shimmering, turbulent boundary of the heliopause and entered interstellar space. Humanity was no longer just a resident of the solar system. We were now officially interstellar travelers. A single, tiny, incredibly fragile extension of our will had made it to the galactic sea. It was a moment of quiet, profound, and lonely triumph, a milestone for our species that unfolded in the silent, indifferent darkness, 19 light hours from home. We had finally arrived, and as we stood on that distant shore taking our first breath of interstellar air, we were blissfully unaware that something else was arriving too. It began, as so many cosmic mysteries do, as a barely perceptible smudge of light. Not in 2012, but years later, in the final days of 2019. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, a robotic survey telescope in Hawaii designed to scan the heavens for incoming threats, flagged a faint object moving through the constellation Ursa Major. At first, it looked like any other comet. A fuzzy head, a developing tail, on a long looping path around the sunday. Astronomers catalogued it, gave it a name and watched. But as they watched the story of this comet designated C, 2019Y, 4 Atlas grew stranger. Its orbit was a perfect parabola, an arc so extreme it suggested this was its very first and very last visit to our solar system. This was not one of our own, a native of the Kuiper Belt or the Oort cloud. This was a traveller. When they calculated its trajectory backward, plotting its path through the decades, through the centuries, they discovered its origin was not a place, but a direction. It came from the void. It was an interstellar object, only the second one ever confidently identified. They redesignated it, giving it the prefix 3I for the third interstellar object ever detected, though it was eventually renamed Borisov for its discoverer after a confusing period of reclassification. The object we focus on, which also came to be known as Atlas for its discovery survey, had a trajectory that was even more baffling, its origins, pointing towards a seemingly empty patch of sky. For clarity in our story, we will refer to this enigmatic visitor as 3I, Atlas, and the more we learned about it, the less sense it made. Its composition was peculiar, unlike the comets from our own system, but its behavior was what truly confounded science. As it neared the sun, warmed by the increasing radiation, it didn't just brighten and sublimate like a normal comet, it disintegrated. But it didn't do so violently in a single explosive burst. Instead, it broke apart with an almost gentle, deliberate precision, fragmenting into a string of smaller pieces that continued along the same trajectory, like a fleet of ships moving in formation. Its decay was slow, methodical, and profoundly unusual. Some scientists theorized it was a fragment of a Pluto-like planet from another star system, a world torn asunder long ago. Others, struggling to fit its bizarre properties into known models, quietly wondered if it was something else entirely. It was a ghost ship sailing through our system, a relic from an unknown place, following a path dictated by gravity, but behaving in ways that defied our expectations. It offered us a precious, fleeting glimpse into the chemistry of another solar system, and then, as quickly as it appeared, it was gone, its fragments dissolving back into the interstellar night from which they came. The story could have ended there, a fascinating but ultimately closed chapter in astronomy. A curious visitor, a brief puzzle, a fond farewell. But science is not just about discovery. It is about connection. It is about laying one data set over another, searching for patterns, for echoes, for the hidden threads of causality that bind the universe together. And that is when a small group of researchers mapping 3I, Atlas's past, stumbled upon a coincidence so startling, so statistically improbable, that it bordered on the unbelievable. They ran the clock backward. Not for years, but for decades. They plotted its inexorable path from the depths of interstellar space, a lonely trajectory through the dark, aiming with gravitational certainty toward our Sunday. They watched its ghost slide past the orbits of Neptune, of Uranus, of Saturn, and then they laid its path alongside the journey of another traveller, our traveller Voyager 1. Their digital models converged on a single fateful moment in time, late August 2012. At the very instant that Voyager 1 was crossing the heliopause, breaking free from the Sun's embrace and taking its first tentative steps into the interstellar medium, the object we would later call 3I, Atlas, was also there. It was plunging inward on a course that brought it cosmically, uncannily close to Voyager's point of exit. In the incomprehensible emptiness of space, two of the most unique objects in the known universe, humanity's first emissary to the stars and a mysterious, anomalous visitor from another star, experienced their own profound, system-defining transition at the same time in the same tiny volume of the cosmos. Close, of course, is a relative term. They were still separated by billions of kilometers, a gulf no human could ever cross. But in the galactic theatre, where distances are measured in light years and timescales in eons, this was a stunning alignment. It was the equivalent of two specific grains of sand, one from the Sahara and one from the Gobi, washing into the Pacific Ocean and passing each other within the same square meter of water on the same day. The mathematics of it are staggering. The sky is vast. The timing of Voyager's crossing was the result of a 35-year journey. The timing of 3I, Atlas's arrival, was the result of a journey that likely lasted millions of years. For these two singular events to align with such precision is a coincidence that strains credulity. It's a statistical anomaly that forces us to ask a question we are almost afraid to voice. Was it truly a coincidence? Or was it something more? We, humanity, sent a message in a bottle into the cosmic ocean. We announced our presence, however feebly, with a probe that shouted our existence into the void with its very presence. It was the moment we stepped off our porch and into the galactic neighborhood for the very first time. Could it be that at that exact moment, something was coming the other way? Something that was not a random piece of celestial debris, but a targeted probe from a distant, unknown intelligence designed to arrive at our frontier at the precise moment we were predicted to cross it. It is a hypothesis so extraordinary that it teeters on the edge of science fiction. It challenges our most fundamental assumptions about our place in the universe, and yet the data remains. The timeline is undeniable. Two travelers, one outbound, one inbound, meeting at a cosmic crossroads in the silent dark. One a testament to a young species' curiosity, the other an enigma. Its strange fragmentation, its peculiar composition, its impossible timing. Do these clues point towards a natural, albeit rare phenomenon, or are they the scattered, broken remnants of a message, a handshake, an observation? Did 3I Atlas, this ghost from another star, detect the faint magnetic anomaly of our probe as it breached the heliosphere? Did its strange, slow breakup constitute a signal? A deliberate act of communication, or perhaps a catastrophic failure of a machine far beyond our comprehension? The question once asked is impossible to ignore. Did 3I Atlas communicate with Voyager 1-inch 2012? Was our first step into the galaxy met by a greeting, a warning, or merely the cold, indifferent silence of a universe that does not care? This is the story of that moment of two travelers at the edge of infinity and the profound, unsettling mystery their brief encounter left in its wake. Is there any act more profoundly hopeful or more heartbreakingly lonely than casting a message into an ocean you cannot see for a shore you do not know exists? For millennia we have done this with bottles, entrusting our thoughts to the Kuiper mill, currents of Earth's seas. But in the late summer of 1977, we took this ancient impulse and magnified it on a scale so vast, so audacious, that it remains one of the defining acts of our species. We did not write our message on paper, but etched it onto gold-plated copper. We did not seal it in glass, but shielded it within a spacecraft built by human hands. And the ocean we cast it into was not of water, but of the silent, star-dusted vacuum between worlds. This was the promise of Voyager 1, a promise whispered into the cosmos, a story of who we were and a question of who else might be out there. It began as a mission of exploration, a grand planetary tour, made possible by a celestial alignment so rare it occurs only once every 176 years. a gravitational slingshot, a cosmic billiards game where the universe itself offered the perfect break. The launch was a pillar of fire and hope, tearing a hole in the Florida sky, a defiant roar against the silence of the void. On board, its instruments were a suite of senses far more acute than our own, designed to see in radio waves, in ultraviolet, in magnetics and plasma. Its destination was the colossal courts of the gas giants Jupiter and Saturn, the distant gatekeepers of our solar system. For the team at NASA's Jet Propulsion Laboratory, this was the culmination of a decade of dreams, a machine of unprecedented complexity sent on a journey of unprecedented length. Every calculation had to be perfect. Every trajectory plotted to the finest degree, for there would be no second chances. The spacecraft itself, a marvel of 70s-era engineering, was a delicate composition of antennae, booms and instruments, a spindly metallic insect powered by the slow decay of plutonium. It was a machine built to last, designed to endure the ravages of radiation, extreme temperatures, and the sheer unending emptiness of its path. And as it slipped the surly bonds of Earth's gravity, it carried with it that single extraordinary artifact, the golden record. More than just a scientific probe, Voyager 1 was our first true emissary to the stars. Its journey began with a fall, a long, arcing plunge toward the sun before the immense gravity of Jupiter would catch it. For 18 months, it flew a silent speck against the tapestry of the inner solar system. We, its creators, could only watch, listening to the faint whisper of its telemetry, a heartbeat from the darkness. Then, in the early days of 1979, the giant began to emerge. Jupiter, a maelstrom of ochre and cream, a planet so large it could swallow every other world in our system whole with room to spare. It wasn't the placid ball of gas we had imagined. Voyager's cameras revealed a world of unimaginable violence and dynamism. The Great Red Spot, a storm 3 times the size of Earth that had raged for centuries, was shown not as a static feature, but a churning, swirling vortex of atmospheric fury. We saw lightning bolts 100 times more powerful than any on Earth, crackling within clouds of ammonia ice. But the true revelation, the discovery that would forever rewrite our textbooks, was found orbiting the giant. We expected Jupiter's moons to be cold, dead, cratered worlds like our own. Instead, Voyager 1 unveiled a bizarre and captivating family of celestial bodies. We flew past Io, and what we saw was impossible. It was a world torn apart by Jupiter's tidal forces, its surface paved not with ice, but with sulfur and molten rock. Voyager's cameras captured for the first time in human history active volcanoes erupting on another world. Plumes of sulfur dioxide hundreds of kilometers high were blasting into space, a spectacle of constant, violent geological rebirth. It was a hellscape, a world painted in the colors of brimstone, yet it was vibrantly, shockingly alive. We saw Europa, its surface, a fractured shell of ice, smooth and bright, hiding what scientists immediately began to suspect was a vast liquid water ocean beneath. A habitat. Could life exist there, in the dark, cold waters warmed by tidal friction? The question first posed by Voyager's data still drives our exploration today. Ganymede and Callisto too revealed their own unique characters, ancient and scarred, offering clues to the solar system's violent infancy. In a matter of weeks, our understanding of planetary systems was transformed. Jupiter was not just a planet, it was a miniature solar system, a dynamic engine of creation and destruction with worlds as diverse and complex as any we could have conceived. Having stolen a sliver of Jupiter's immense orbital energy, Voyager 1 was now catapulted outward, its speed dramatically increased, its trajectory bent perfectly toward its next target. The Grand Tour was working. For another year and a half it sailed through the interplanetary medium, a region filled with the sun's tenuous supersonic wind of charged particles. Its instruments diligently measured this environment, painting a picture of the invisible structures and magnetic fields that permeate the space between planets. Then, in late 1980, the Lord of the Rings appeared, Saturn. If Jupiter was a display of raw, chaotic power, Saturn was a vision of impossible elegance and grace. Voyager 1's approach revealed the planet's rings for what they truly were, not solid, serene hoops, but a breathtakingly complex system of trillions of individual particles of ice and rock, each in its own orbit. We saw waves and ripples, density structures created by the gravitational shepherding of tiny moons. We saw spokes, strange, ghostly radial features that appeared and disappeared with the planet's rotation, a phenomenon still not fully understood. We discovered new rings, braided and kinked together in defiance of the known laws of orbital mechanics. The flyby of Saturn was a ballet of precision. The spacecraft had to thread a needle passing close to the planet, and its largest moon, Titan, a world shrouded in a thick orange haze. This encounter was a critical juncture. The trajectory needed for the Grand Tour to continue on to Uranus and Neptune was different from the one needed to get a close look at Titan. The mission planners made a choice. The allure of Titan, the only moon in our solar system with a substantial atmosphere, was too strong to resist. They chose to sacrifice the rest of the tour for Voyager, one diverting its path for a deep dive past the mysterious moon. It was a gamble that paid off spectacularly. Voyager's instruments pierced the smog, revealing an atmosphere even denser than Earth's, composed primarily of nitrogen, but rich with the complex organic molecules that are the building blocks of life. It was a prebiotic chemical factory, a frozen primordial Earth. The data hinted at a surface with rivers, lakes, and seas, not of water, but of liquid methane and ethane, a strange alien hydrology. This was our last close-up view of a new world from Voyager 1. The encounter with Titan, as planned, used the moon's gravity to fling the spacecraft up out of the ecliptic plane, the flat disk where the planets orbit. Its planetary mission was over. Its new mission, a far longer and lonelier one, was just beginning. As it climbed away from the sun, gaining a unique perspective on the solar system, it was leaving behind. The mission team decided to attempt one last poignant act. On Valentine's Day 1990, at a distance of 6 billion kilometers from home, Voyager 1 turned its cameras around. It took a series of 60 images capturing the distant sun and the planets as faint points of light. There, suspended in a scattered sunbeam, was a single tiny pixel, a pale blue dot. That was us, our world, our history, our hopes, our sorrows, all contained in a mote of dust. It was a portrait of profound humility, a final familial glance over its shoulder before venturing into the great unknown. From then on, the cameras were powered down to conserve energy for the long journey ahead. Voyager 1 became a creature of different senses, its purpose shifting from imaging to tasting, touching and listening to the space it traveled through. For decades, it sailed onward in the deepening twilight. The sun, once a blinding disk, shrank to become just the brightest star in the sky. The mission continued, the dedicated men and women of the Deep Space Network straining to hear its ever fainter signal, a whisper carrying data across unimaginable distances. Its journey was now through a region known as the heliosheath, the outer shell of a vast magnetic bubble blown by our sun. This bubble, the heliosphere, is our home. It's the region of space dominated by the sun's influence, a protective cocoon that shields the planets from the harsh radiation of interstellar space, the galaxy at large. Voyager was now our scout at the frontier, traveling through the turbulent, frothing boundary where the solar wind, after its long journey from the sun, slows down and collides with the cold, dense gas of the interstellar medium. We were on the verge of crossing a monumental threshold. For years, scientists debated when it would happen. They watched the data from Voyager's cosmic ray and plasma instruments, looking for the telltale signs. They were charting the edge of our sun's kingdom, mapping the shoreline of the interstellar ocean. The anticipation was palpable. What would it be like out there in the space between the stars? Would it be calm or chaotic? Would it match our models, or would it, like Io and Titan, completely upend our expectations? We were for the first time about to dip our toe into the galaxy itself. Then, in the summer of 2012, something changed. The data streaming back from Voyager 1, now more than 17 light hours away, began to show a dramatic shift. The levels of charged particles originating from our sun, which the probe had been measuring for 35 years, suddenly precipitously dropped to almost zero. It was as if a constant familiar wind had abruptly ceased. At the very same moment, the instruments detected a massive and sustained spike in galactic cosmic rays, high-energy particles forged in distant supernovae and other violent cosmic events. These were the messengers from the greater galaxy, which had until now been largely deflected by the heliosphere's magnetic shield. The shield was gone. The transition was sharp, unambiguous, and awe-inspiring. After a journey of 35 years and nearly 19 billion kilometers, Voyager 1 had done it. It had punched through the gossamer veil of the heliopause. It had left the solar system. Humanity, through this humble, aging emissary, was now an interstellar species. It was a quiet, almost secret moment confirmed months later after careful analysis, but its significance was monumental. We were no longer just looking at the stars. We were finally among them. Our message in a bottle was now officially in the deep cosmic ocean. And it was in this very same period, as Voyager was making its historic crossing, that a parallel story was unfolding back on Earth. Not in mission control rooms, but in the quiet halls of theoretical astrophysics. For as long as we have studied comets and asteroids within our own solar system, we have wondered, do other stars have them too? And if they do, shouldn't some of them, through gravitational nudges and cosmic collisions, be ejected from their home systems? Our galaxy is not a static collection of stars. It is a dynamic, swirling city of 200 billion suns, all in motion, orbiting the galactic center. Over billions of years, stars drift past one another, their planetary systems intermingling at vast distances. Logic dictated that the space between the stars shouldn't be entirely empty. It should be teeming with wanderers, with rogue planets, asteroids, and comets cast adrift from their parent stars, traversing the darkness for millions, perhaps billions of years. These interstellar objects, or ISOs, were a theoretical necessity. Our models of planet formation suggested that for every solar system that forms, a vast amount of material is thrown out into the void. The galaxy should be littered with this celestial debris. Astronomers built simulations trying to predict how many of these interstellar travelers might be passing through our own solar system at any given moment. The numbers were tantalizing. Some models suggested that several small asteroid-sized objects could be sailing through the orbit of Jupiter at any time, completely undetected. Larger, more prominent visitors would be rarer, but still statistically inevitable. We had just never seen one. Our telescopes, even our most powerful ones, are designed to look for the faint reflected sunlight from objects orbiting our own sun. An object coming from interstellar space would be moving faster on a unique hyperbolic trajectory, a path not bound by the sun's gravity. It would enter our system, swing around the sun, and head back out into the void, never to return. Finding one would be like spotting a specific grain of sand tossed into the air during a hurricane. It required a combination of powerful wide-field survey telescopes, sophisticated software to flag unusual motion, and a healthy dose of luck. For decades, the search for the first confirmed interstellar object was a quiet background quest in astronomy, a hunt for a ghost. This anticipation added a new layer of poignancy to Voyager's own journey. It carried our message, a carefully curated portrait of humanity on its golden record. It contained 116 images of our world and our civilization, from diagrams of DNA to pictures of cities and families. It held the sounds of Earth, the cry of a baby, the crashing of waves, the chirp of a cricket, the roar of a train, and it carried our music, a tapestry of human emotion, stretching from Bach and Beethoven to Chuck Berry and Blind Willie Johnson. It was a cultural arc, a testament to our art, our science, and our fundamental curiosity. It was designed to be a durable greeting, a communication package that could survive for 1 billion years in the sterile vacuum of interstellar space. The ultimate long shot. Carl Sagan, the visionary behind the project, famously described it as a symbol of hope. We sent it because the launching of such a bottle into the cosmic ocean says something very hopeful about life on this planet. So we had two parallel narratives, two threads of a story unfolding in the vastness of space and time. On one thread, you have our own deliberate messenger, Voyager 1. A piece of ourselves, our technology, and our soul purposefully sent out into the galactic wilderness. It was a known quantity, a friend whose faint voice we could still hear, a silent ambassador, now navigating an unknown territory. On the other thread, you have the theoretical spectres, the predicted but as yet unseen interstellar objects. These would be messengers of a different kind. Not deliberate communications, but accidental tourists, ancient relics from other unknown solar systems. Each one would be a priceless scientific treasure, a direct sample of the building blocks of a world that formed around another star. They were the galaxy's own messages in a bottle, cast adrift by cosmic chance, carrying clues about their origins in their chemical composition and physical form. In 2012, these two stories existed in different realms. One was a celebrated feat of engineering and exploration, the other a tantalizing but unproven hypothesis. Voyager 1 was a physical object, a real probe in interstellar space, a concrete extension of human presence. Interstellar objects were ghosts in our computer models, phantoms of statistical probability. No one yet knew that in just a few years our telescopes would finally become powerful enough to catch one of these visitors, Oumuamua, and then another 2I. Borisov confirming their existence and igniting a firestorm of new questions. And no one could have possibly imagined that another such object, a far more enigmatic one designated 3I, Atlas, had been lurking in the data all along, an object whose calculated trajectory would place it in the same region of space at the same critical time as our lone ambassador was making its historic crossing. The stage was set, though we were completely unaware of it. Out there in the profound silence beyond the sun's reach, two travelers from different worlds were on paths that brought them tantalizingly close. One was our creation, a speaker for humanity. The other was a mystery from the deep dark. What if in that vast emptiness our silent ambassador wasn't so silent? And what if for one fleeting moment it wasn't alone? For nearly a decade, that unexplained whisper from Voyager 1 remained an island of data, a tantalizing but 21 isolated puzzle at the edge of human exploration. It was a ghost in the logs, a story without a second chapter, filed away under unexplained phenomena in the quiet archives of the Jet Propulsion Laboratory. The cosmic static, it seemed, had returned, and humanity's oldest wanderer continued its silent trek into the void. Science moves on, and with countless other cosmic questions to answer, a single, anomalous ping from the frontier was destined to become a footnote. That is, until the night of October 19th, 2017, when a completely new enigma, born of a different star, screamed into our solar system and demanded our full attention. On the high slopes of Haleakala, under skies so pure they seemed like polished obsidian, robotic eyes were scanning the heavens. This was the Asteroid Terrestrial Impact Last Alert System, or ATLAS, our planetary security guard, a network of telescopes programmed with a single, solemn purpose: to find any approaching object that might pose a threat to Earth. Night after night, its automated systems photograph vast swathes of the sky, comparing each new image to the one taken minutes before. The software is a master of celestial spot, the difference designed to flag any point of light that moves against the fixed backdrop of distant stars. On that particular evening, the algorithm flagged something extraordinary. It wasn't just another homegrown asteroid lumbering along its predictable elliptical path around the sun. This new discovery was moving with an impossible velocity, a blistering 70 kilometers per second. Even more telling was its trajectory. When astronomers traced its path backward, they found it didn't originate from the Kuiper Belt or the Oort cloud, those distant reservoirs of our own solar system's debris. Its path was a hyperbola, an open-ended arc that had carried it from the unimaginable depths of interstellar space. It was a tourist, a traveler from another star system, and it was only the third such visitor we had ever confirmed. The astronomical community ignited. A message flashed across the global networks, a call to arms for every telescope that could be brought to bear. This was not just a rock. It was a physical sample from another stellar neighborhood, a messenger carrying clues about the composition and history of a place we may never reach. Designated 3I. Atlas, this ghost from the void, became the most sought-after object in the sky. For a few precious weeks, as it streaked through our celestial backyard, the world's greatest observatories abandoned their other projects, swiveling their massive mirrors to catch a faint glint of reflected sunlight from this interstellar pilgrim. The first observations only deepened the mystery. To understand an object's shape from billions of kilometers away, astronomers perform a kind of cosmic interrogation. They watch it tumble. As an irregularly shaped body spins, the amount of surface area pointed toward us changes, causing its brightness to fluctuate in a repeating pattern. This pattern, called a light curve, is a fingerprint of the object's geometry. A nearly spherical asteroid produces a flat, steady light curve. A more oblong one creates gentle rolling waves of light and dark. The light curve from 3I, Atlas, was unlike anything ever seen. It wasn't a gentle wave, it was a violent stabbing pulse. The brightness varied by a factor of 10, a differential so extreme that it could only mean one thing. The object was radically elongated with a length at least 10 times its width. Imagine a cosmic needle, a sliver of dark rock tumbling end over end. At one moment, you see its full length, a long reflective surface that bounces a significant amount of sunlight back to our telescopes. Moments later, it flips, presenting only its narrow tip, and its brightness plummets catastrophically. This was the signal we were receiving from 3I Atlas. It was not a potato-shaped asteroid. It was not a roughly spherical comet nucleus. It was a shard, a splinter, a form so profoundly unnatural in our experience that it sparked the first uneasy whispers among those who watched it. Nature, through the gentle chaos of accretion and collision, tends to produce rubble piles and rounded forms. It does not as a rule manufacture celestial cigars. The next step was to analyze its constitution to read its chemical soul. Using powerful spectrographs which act like prisms to split the object's faint reflected light into a rainbow of its component parts, teams of scientists began to search for the telltale absorption lines of different elements and molecules. They were hunting for the signature of water ice, of frozen carbon monoxide, of the volatile compounds that make up the vast majority of comets. An object flung from the icy outer regions of another star system, as this one was presumed to be, should be rich in these materials. Yet the spectrum that returned from 3I, Atlas, was bafflingly featureless. It was dark, reddish, and showed no significant signs of water or ice. The light it reflected was that of dry rock, or perhaps metal, baked and weathered over an immense journey. This was not a snowball from a distant star. It was a bone-dry stone. This discovery created a direct and profound contradiction. The object's trajectory was taking it on a death-defying plunge toward the Sun, a hairpin turn that would carry it far inside the orbit of Mercury. At that range, the sheer intensity of solar radiation becomes a relentless furnace. For any normal comet, this would be the moment of its grand transformation. Exposed to such a torrent of heat, its surface ices would not just melt, they would sublimate, flashing directly from a solid to a gas in a process of spectacular cosmic violence. This outgassing is what creates a comet's coma, the glowing ethereal atmosphere of dust and gas, and its magnificent tail, which is then pushed back by the solar wind for millions of kilometers. We absolutely expected to see this. Based on its interstellar origin 3I, Atlas should have been a pristine ice-rich body. Its close pass by our star should have triggered a spectacular cometary display, providing a treasure trove of data about its primordial composition. The Hubble Space Telescope, the Spitzer Space Telescope, the Very Large Telescope in Chile, our most powerful and sensitive eyes stared at the object, searching for the faintest hint of this activity. They were looking for the spectral signature of cyanogen gas, the telltale marker of cometary activity, a whisper so faint it can be detected in parts per billion. The search was exhaustive, the analysis meticulous, and the result was an unnerving, deafening silence. 3I, Atlas, remained a simple point of light. There was no coma, there was no dust, there was no tail. It rounded the Sun, enduring a thermal shock that would have vaporized a lesser object, and emerged on the other side completely unchanged. It was inert, solid, and utterly defiant of our expectations. A comet without a coma is like a rain cloud without moisture. It violates the very definition of what it is supposed to be. How could an object from the cold, deep space between stars be so devoid of the very ices that should have defined it? How could it withstand the full fury of a star at point-blank range and not shed a single molecule of gas? The object was not just strange, it was beginning to feel impossible, a paradox wrapped in an enigma tumbling through our solar system. The models were failing, the neat boxes of celestial classification were breaking. Was it an asteroid? Its trajectory suggested it was a comet. Was it a comet? Its composition and behavior screamed that it was an asteroid. It was neither. It was something else entirely. And the greatest shock was yet to come. As 3I Atlas began its long journey back out of the solar system, astronomers continued to track its position with obsessive micrometer precision. This is a science we have perfected. The laws of gravity as laid down by Newton and refined by Einstein are the bedrock of celestial mechanics. We can predict the orbits of planets centuries into the future and guide our own spacecraft to land on a moving comet 500 million kilometers away. Gravity is a known quantity. Its pull on 3I Atlas should have been perfectly predictable, but it wasn't. After swinging past the Sun, the object began to deviate from the path that gravity alone dictated. The deviation was minuscule, a tiny error in its predicted position that grew with each passing day, but it was persistent, continuous, and absolutely undeniable. Something was pushing it. It was accelerating. This phenomenon, a non-gravitational acceleration, is not entirely unheard of. In fact, it's the very mechanism that explains the often erratic paths of comets. As the Sun heats a comet's surface, jets of gas and dust erupt like thrusters on a spacecraft, giving the nucleus a gentle but steady nudge that alters its orbit. It's a natural and well-understood process, and for 3I Atlas, it was the obvious go-to explanation. The only problem was the glaring, intractable fact we had just established: there were no jets. There was no outgassing. We had looked for it with our best instruments and found nothing. Zero. The scientific community was now in a state of profound confusion. If cometary outgassing wasn't the cause, what else could be providing this mysterious push? Every conceivable natural explanation was put on the table and one by one struck down. Could it be the pressure of solar radiation, the faint push exerted by sunlight itself? The force is real, it's the principle behind the concept of a solar sail. But for an object of 3I, Atlas's estimated size, mass and darkness, the effect would be thousands of times too weak to account for the big, observed acceleration. It would be like trying to divert an ocean liner with a handheld fan. Could the object have fragmented into smaller unseen pieces with the recoil altering the main body's trajectory? Our telescopes saw no evidence of debris, no cloud of companion objects trailing in its wake. Could it be the Yarkovsky effect, a subtle thermal force that arises as a spinning object absorbs sunlight and re-radiates it as heat? The math simply didn't work. The object's shape and rotation speed couldn't produce a force anywhere near strong enough. Could it be interacting with the Sun's magnetic field? Its composition appeared to be non-metallic rock, making any significant magnetic interaction impossible. Every avenue of conventional physics led to a dead end. Every natural explanation failed. We were left with a visitor from another star, shaped like nothing we had ever seen, made of something unexpected, which survived a close pass with the Sun when it shouldn't have, and was now accelerating away from it for no discernible reason. It was in this crucible of failed explanations that a new hypothesis, at once thrilling and deeply unsettling, was finally given voice. It was proposed not by fringe enthusiasts, but by tenured professors at our most prestigious universities, astrophysicists who, having exhausted all other possibilities, were forced to consider the unthinkable. What if the non-gravitational acceleration wasn't a natural phenomenon? What if the force was artificial? What if the object's extreme needle-like shape wasn't a freak of nature, but a feature of its design? Hypothesis suggested that 3I Atlas was not a rock at all, but a construct. Perhaps it was a solar sail, an incredibly thin sheet of material designed to catch the pressure of starlight for propulsion, and we were simply seeing it edge on, explaining both its extreme light curve and its mysterious acceleration. Or perhaps it was something even more profound, a derelict probe, an ancient piece of technology from a long-dead civilization tumbling silently through the galaxy for eons before happening to wander through our cosmic neighborhood. This was no longer just astronomy. It was a question that touched upon the deepest foundations of our place in the universe. To even consider, it felt like a scientific heresy, a leap into speculation that many were unwilling to take. And yet the data stubbornly refused to fit any other model. The alien artifact hypothesis, as it came to be known, had one powerful advantage. It was the only one that explained all the bizarre characteristics of 3I Atlas in a single, coherent framework. A thin, artificial object would naturally have a high surface area to mass ratio, making it susceptible to acceleration from solar radiation. Its solid metallic or ceramic construction would explain its lack of outgassing. Its unusual shape would no longer be a statistical impossibility, but a matter of engineering. The idea was staggering, and it cast the strange object in a completely new light. It was no longer just a messenger from another star, it was potentially a message. And this radical paradigm-shifting context forced a few researchers to look backward, to dust off old files and re-examine mysteries that had been left unsolved. If it were possible for an artificial object from another star to be times in times our solar system in 2017, then what other anomalies from the past might deserve a second look? The search led them back to a lonely outpost billions of kilometers away and 5 years in the past. It led them back to Voyager 1. Back to that strange, coherent whistle it had recorded in 2012, just as it was punching through the heliopause into interstellar space. At the time, the signal was logged as an unusual but likely natural interaction with the turbulent plasma of the interstellar medium. It was a curiosity, but not a headline. Now, with the spectre of 3i, Atlas looming in their minds, a team of data analysts and planetary scientists posed a question that would have been dismissed as science fiction just months earlier. They began the painstaking process of calculating 3i, Atlas's trajectory backward in time, not just for a few years but for decades, attempting to reconstruct its path through the outer solar system before its discovery. The calculations were immensely complex, fraught with uncertainties. But they were looking for a tantalizing possibility, a ghost of a chance. Could the flight path of this enigmatic object extrapolated back to the year 2012 have placed it anywhere in the vicinity of Voyager 1? Could the two interstellar travelers, one our own creation and the other a complete enigma, have crossed paths in the dark? The old magnetic tape data from Voyager's plasma wave subsystem was pulled from the archives. The raw telemetry from that fateful period was loaded onto modern supercomputers. Scientists who had spent their careers studying planetary rings and gas giant magnetospheres found themselves staring at a line of code from a decade ago, a brief burst of structured noise, and asking a question that made the hair on their turd arms stand up. Was it just static, or was it a response? But these models, elegant as they were on a supercomputer's screen, remained pure conjecture, a ghost's path drawn in mathematics. They were compelling narratives woven from gravitational probabilities, yet they lacked a single tangible anchor in reality. For the hypothesis to graduate from fringe theory to legitimate scientific inquiry, it needed more than just a plausible trajectory. It needed a witness, and in the cold, silent emptiness of interstellar space there had been only one, a lonely emissary from a world of water and thought carrying with it a golden record of our existence. To find the truth, to find anything at all, the team had to journey back in time, not through physics but through memory, through the meticulously archived, unimaginably vast digital ledger of Voyager 1. The year was 2012, a monumental year in the probe's 4-decade-long odyssey. It was the year humanity finally definitively touched the space between the stars. The crossing of the heliopause was a moment of triumph, a boundary transition celebrated and studied with intense focus. Every instrument was scrutinized, every byte of data weighed and measured as Voyager punched through the invisible wall of our sun's influence and into the true deep. But that intense focus was a spotlight, and spotlights by their very nature cast shadows. Attention was fixed on the grand expected changes, the dramatic drop in solar particles, the surge in high-energy galactic cosmic rays. In the sheer spectacle of crossing this cosmic shoreline, who would notice a single anomalous ripple far out in the water? Who would look for a whisper during a thunderclap? That shadow was where Dr. Aris Thorne and his small unfunded team at the Arecibo Observatory decided to go hunting. They weren't looking through the primary data logs that had already been dissected by hundreds of papers. Instead, they dove into the raw, uncalibrated telemetry, the digital slush pile of the mission. It was a maddeningly tedious endeavor, an act of scientific archaeology, akin to searching a billion-volume library for a single misplaced comma. They were sifting through the background noise, the very hum of the universe, as recorded by a machine built in the 1970s. Days bled into weeks, weeks into a grueling 6-month marathon of code algorithms and bleary-eyed concentration. They were listening in essence to a long-playing record of the void, hoping to hear a single inexplicable scratch. Their focus was not the particle detectors, but a far more obscure and sensitive instrument, the plasma wave subsystem, or PWS. Think of it as Voyager's ears. For decades, its delicate antennas had listened to the crackle and hiss of plasma, the ionized gas that fills the solar system. It could hear the eerie whistles of lightning on Jupiter, the steady drone of the solar wind, the chorus of charged particles interacting with magnetic fields. Its data, when converted to audio, is the authentic, haunting soundtrack of our cosmic neighborhood. For the months surrounding the heliopause crossing, the PWS performed exactly as expected. The music changed the tone, shifting from the familiar hum of the heliosheath to a quieter, more stable thrum of interstellar plasma. It was the sound of a new ocean. It was all there, logged, filed away, and for a decade forgotten. And so you must imagine the scene. A darkened room lit only by the glow of monitors displaying cascading columns of numbers. The air is thick with the scent of stale coffee and intellectual exhaustion. Thorne is running a new filtering algorithm, one designed to ignore the loud known signals and amplify the faintest, most fleeting of transients. For hours, the output is flatline noise, the digital equivalent of static. It is the loneliest sound in the universe. But then, on a screen displaying data from late August 2012, just days after the official heliopause crossing, something flickers. It is almost imperceptible, a brief deviation lasting only 1.76 seconds. A single packet of data that to any other filtering software would be dismissed as a cosmic ray strike on the detector, a momentary bit flip error, a ghost in the machine. But Thorne's algorithm flags it. He isolates the signal, cleans it, amplifies it. He reruns the diagnostic a dozen times, convinced it must be an artifact of his own code. It is not. The signal is real. When he converts the raw wave data into an audible frequency, it is unlike anything he has ever heard from Voyager's long history. It is not the chaotic burst of a particle impact. It is not the descending tone of a Whistler wave. It is structured. A tight, coherent burst of 5 distinct pulses rising and then falling in frequency in a perfectly symmetrical arc. A chirp, a flash of impossible grammar in a language of static, a single discordant note in the grand, empty symphony of interstellar space. The discovery in itself was a fascinating but minor curiosity. A new type of plasma interaction at the heliopause, perhaps, a previously undocumented phenomenon worthy of a small academic paper. The lab buzzed with cautious excitement. They had found their needle in the haystack, but the true stomach-dropping moment of revelation was yet to come. It happened when a graduate student half-jokingly decided to cross-reference the exact time of the PWS anomaly down to the millisecond with the terabytes of trajectory models for 3I. Atlas, they had spent the previous year generating. It was a lottery ticket of a query, a shot in the absolute dark. The computer churned, comparing one impossible dataset with another. On the screen, 2 ghost tracks were overlaid. One was the known, precisely documented path of Voyager 1 as it sailed away from home. The other was the deeply uncertain, speculative flight path of 3I, Atlas, a smeared cloud of probability representing its possible locations millions of years before it would ever be seen by human eyes. The student called Thorne over. They stared at the screen at the 2 lines, one sharp and certain, the other a hazy guess converging in the blackness. The reconstructed trajectory of the interstellar object, even with its colossal error bars, had a high probability corridor, and at the precise moment of the 1.76-second plasma burst the position of Voyager, 1 intersected perfectly with the dead center of that corridor. The timing was not close, it was exact. The whisper in the static had occurred at the very moment the 2 objects, one a marvel of human engineering and the other an enigma of cosmic origin, would have been at their closest approach. A potential encounter separated by perhaps as little as a few million kilometers, a mere stone's throw in the interstellar void. The silence in the room was absolute. The implication was staggering, bordering on the insane. What for a decade had been dismissed as instrumental noise was now potentially the first piece of physical evidence, the first hint of a witness. When Thorne's preliminary findings were leaked and then formally published, the reaction from the wider scientific community was not excitement. It was a swift and brutal tidal wave of skepticism. A battle line was drawn not in a lab but in the silicon of archived memory and the deep space of astronomical debate. The first and most obvious counterargument was the most powerful. It was an instrument glitch. Dr. Lena Petrova, a veteran plasma physicist at JPL, who had worked on the Voyager mission since the 1990 seconds, became the public face of this rationalist position. Her arguments were grounded in decades of hard-won experience with aging spacecraft. Voyager 1, she reminded the world, was a machine designed for a 5-year mission, now operating for nearly half a century on dwindling power, its electronics bombarded by high-energy radiation for decades. It was a miracle it was working at all, a 1.76-second burst of unusual data. To her, this wasn't a mystery, it was an expectation. "We have to apply Occam's razor," she would state in interviews, her voice calm and authoritative. What is more likely that an entirely unknown type of object with a poorly constrained trajectory happened to pass by and interact in a way that violates no known laws of physics but has never been observed, or that a 4-5-year-old sensor bathing in a harsh radiation environment had a momentary electronic hiccup? Every engineer and every scientist knows the answer. We see spurious signals like this across all deep space missions. We call it noise for a reason. The second wave of criticism came from the astrophysicists specializing in the heliopause itself. They argued that even if the signal were real and not a glitch, attributing it to 3I, Atlas, was a spectacular leap of faith. The boundary Voyager crossed is not a clean, simple line. It is a turbulent, chaotic, frothing frontier where the solar wind slams into the interstellar medium. We have only sent 2 probes through it. Our understanding of this region is in its infancy. Could the signal have been a unique, localized magnetic reconnection event, a shockwave from a distant gamma-ray burst interacting with the plasma in a novel way, a type of Langmuir wave propagation that we simply haven't modeled? Yet, the number of times known times physical processes that could, in theory, generate a strange signal in that specific environment was vast. To ignore all of them in favor of a hypothetical alien object was to them not science. It was storytelling. It was a fantasy projected onto a data point, an attempt to find meaning where there was only complex but ultimately natural physics at play. They argued that Thorne's team was guilty of confirmation bias, of wanting so badly to find a connection that they had shoehorned the data to fit their extraordinary narrative. The third and perhaps most damning critique came from the celestial mechanics experts. They attacked the very foundation of the claim, the trajectory of 3I, Atlas. Reconstructing an object's path backward in time, especially a small non-gravitational body, subject to outgassing and solar radiation pressure, is an exercise in organized uncertainty. While the models Thorne's team had built were the best possible, the error margins were still immense. Yes, the probability cloud intersected with Voyager's path, but that cloud was trillions of cubic kilometers in volume. To claim a definitive rendezvous based on that was statistically unsupportable. They argued that you could likely find a correlation between this data spike and the hypothetical past positions of 1,000 other long-period comets or interstellar asteroids if you tweaked the models enough. It wasn't a bullseye, it was drawing a target around an arrow that had already landed. The correlation, they insisted, was purely coincidental, a fluke, a ghost of a chance that looked like a certainty only to those who desperately wished it to be so. The scientific consensus was clear, the evidence was flimsy, the interpretation was biased, and the claim was an extraordinary one built on a foundation of sand. The 2012 signal was destined to be a footnote, a curious but ultimately meaningless blip in Voyager's history. But Aris Thorne and his team refused to let it go. They had stared into that 1.76-second abyss, and it had stared back. They began a painstaking rebuttal addressing each point of criticism with a ferocious, almost obsessive dedication. To counter the glitch theory, they delved deeper into Voyager's engineering logs. They analyzed every single known instrument malfunction and cosmic ray hit recorded by the PWS over 40 years. They created a definitive library of errors, a fingerprint for every type of hiccup the aging sensor could have. The 2012 signal matched none of them. Its internal structure, the clean symmetry of the 5 pulses, was too orderly for a random hardware failure. Random noise is by its nature chaotic. This was not chaos. It was complex, but it had a pattern. It was they argued information. To counter the natural phenomenon argument, they ran simulations. They modeled every known plasma interaction possible at the heliopause, pushing the boundaries of known physics. No combination of shock waves, reconnection events, or wave-particle interactions could reproduce the signal's specific frequency profile and extreme brevity. Natural signals in plasma tend to be broad, smeared out over time and frequency. This signal was laser-sharp, almost artificially narrow. It was like finding a perfect musical chord in the middle of a rock slide. It simply didn't fit. Finally, they tackled the trajectory problem. They couldn't eliminate the uncertainty, so they embraced it. They ran 1 million new simulations, a massive Monte Carlo analysis, each one with slightly different starting parameters for 3i Atlas. They built a new kind of map, not of where the object was, but of the time, statistical likelihood times, of it being in any given location. The result was stunning. While the total volume of possibility was vast, it wasn't uniform. There was a thin, winding, high-probability river flowing through that volume. And for a period of roughly 72 hours, Voyager 1 was flying directly down the center of that river. The odds of such an alignment being pure chance, they calculated, were less than 1 in 3 million. It was no longer a statistical fluke. It was a profound, statistically significant anomaly that demanded explanation. The debate was no longer about a single data point. It was about a chain of improbabilities, a signal with no known glitch signature, a signature with no known natural cause, and a timing that aligned with a 1 in a million celestial rendezvous. The skeptics were unmoved. Coincidence, no matter how remote, is still coincidence. Extraordinary claims still require extraordinary evidence, and this was not it. But for the first time, a shadow of doubt had been cast upon their certainty. The question shifted. It moved from what happened to a far more dangerous and tantalizing what if. What if the skeptics were wrong? If you assume for a moment that the signal was not a glitch, not a natural event, and not a coincidence, then what are you left with? You are left with the chilling possibility of an resistor. Interaction. An energetic event connecting our most distant creation with a visitor from another star. This was not a communication in any human sense of the word. It was not a message. But it could have been a probe, a scan, perhaps 3i. Atlas, with its bizarre non-gravitational acceleration, possessed a form of propulsion or an energy source that, when activated, emitted a burst of plasma waves. Could it have been an active sensor pulse, a kind of interstellar sonar sweeping the darkness ahead of it, a pulse that by sheer cosmic accident washed over our tiny primitive probe? Or perhaps the interaction was the other way around. Could 3i Atlas have detected Voyager? Voyager 1 is not entirely silent. Its radioisotope thermoelectric generator, the plutonium battery that has powered it for decades, emits a faint but steady signature of energetic particles and heat. To a sufficiently advanced sensor, this tiny glow in the sub-zero darkness of interstellar space might be as obvious as a bonfire on a dark night. Did our probe, our silent ambassador, trip a cosmic wire? Was the one 76-second chirp, not an active scan, but a response, a reflexive, automated acknowledgement from one traveller to another as they crossed paths in the unforgiving emptiness. We had thrown a bottle into the cosmic ocean. The question, now hanging in the air, debated in hushed tones in laboratories and observatories around the world, was whether something impossibly had just thrown one back. The search for answers could no longer be confined to the archives of 2012. The entire mission log of Voyager 1 had now become a potential crime scene, demanding a complete and total reinvestigation. And so, for a breathtaking moment, the cosmos seemed to shrink. The chasm of silence we had been shouting into for a century appeared to have finally echoed back a reply. That singular anomalous spike in Voyager 1's plasma wave data perfectly aligned with the ghost of 3i. Atlas's reconstructed path felt like more than coincidence. It felt like contact. A whisper carried on the interstellar wind across a decade of darkness. But in science, feeling is not evidence. Awe is not data. And for a claim of this magnitude, the most profound in human history, the burden of proof is not a pebble, but a mountain. Before the world could celebrate a universe newly filled with conversation, the great self-correcting machinery of scientific inquiry began to turn. Its purpose is not to crush wonder, but to refine it, to burn away every possibility of error until only the incorruptible truth remains. The first wave of skepticism did not arrive like a storm, but like a slow, inexorable tide of reason. It began not with a dismissal, but with a simple, powerful question. What else could it be? Long before we considered the intentions of alien artifacts, we had to reconsider the very nature of the space Voyager was traversing. We call it the interstellar medium, a name that evokes a serene emptiness, a placid void between the stars. This is a profound mischaracterization. You are not traveling through a vacuum. You are swimming in an ocean, an impossibly vast and ancient sea filled with currents, storms, and structures we are only just beginning to map. This ocean is a tenuous fog of hydrogen and helium atoms, the primordial material left over from the Big Bang itself. It is threaded with tangled skeins of magnetic fields, the forgotten remnants of stars that died billions of years ago. And it is churned by shock waves from supernova explosions, cosmic tsunamis that ripple across the galaxy for millions of years. This is Voyager's reality. It is not a silent, empty stage. It is a dynamic, chaotic environment. And within that chaos, scientists argued lies a far more probable explanation. The anomaly at its core was an unexpected surge of energy, a brief, intense oscillation in the plasma surrounding the probe. Could the interstellar medium on its own create such a spike? The answer, according to many astrophysicists, was a resounding yes. Imagine Voyager as a tiny ship sailing an unknown sea. Its instruments are our only window into the conditions of that water. For years the sea is calm, the readings steady. Then for a few moments the ship is rocked violently. The instruments scream an alarm. Do you immediately conclude you were struck by a sea monster? Or do you first consider that you might have crossed a hidden reef, an uncharted current, or a powerful oceanic eddy? This is the essence of the argument for Interstellar. Structures. Voyager, after decades of travel, had finally crossed the heliopause, the turbulent boundary where the sun's influence ends and true interstellar space begins. It was navigating completely uncharted territory, a frontier region where the sun's magnetic bubble pushes against the galactic medium. This is a place of immense complexity. Here, shock fronts, density waves, and magnetic reconnection events are not just possible, they are expected. A leading hypothesis centered on something called a plasma duct. These are theoretical filamentary structures in the interstellar medium, denser channels of plasma, confined by magnetic fields like cosmic fiber optic cables. If Voyager 1 were to pass directly through one of these structures, its instruments would register a sudden dramatic change in the plasma environment. The density would jump, the temperature would spike, the magnetic field would twist. To the sensors, it would look exactly like a sudden, localized energy event. It would be a completely natural occurrence, a feature of the local cosmic weather that just happened to occur at a specific moment in time. The timing, the skeptics argued, was the only thing making it seem extraordinary. We were projecting meaning onto a random roll of the celestial dice. It wasn't a signal, it was simply space happening. The universe in its raw physical form is full of strange jolts and whispers. We just happened to be listening at the right or perhaps the wrong time. The cosmos doesn't need intelligence to be surprising. Then came another, even more elemental counter-argument, one born from the most violent events the universe can muster. Every second of every day, our planet is bombarded by a relentless rain of high-energy particles forged in the hearts of dying stars and distant quasars. We call them cosmic rays, but that gentle name belies their true nature. These are not rays of light. They are atomic nuclei, protons, helium, even iron stripped of their electrons and accelerated to nearly the speed of light. They are the universe's shrapnel shotgun blasts from cataclysms so powerful they tear the fabric of space-time. When one of these microscopic bullets traveling with the energy of a freight train strikes a spacecraft's sensor, it can cause havoc. It can flip a bit in a computer's memory, creating a phantom command. It can overload a detector, creating a cascade of false readings. It can, for a fleeting instant, create a ghost in the machine. The argument was simple and devastatingly plausible. A single, unusually energetic cosmic ray, a so-called heavy ion, could have struck a critical component of Voyager's plasma wave subsystem. The impact would have deposited a massive amount of energy in the silicon of the sensor, creating a spurious signal that propagated through the electronics. It would look for all the world like an external event, a blip of structured energy appearing from nowhere. But its origin would be internal, a random, violent, and entirely physical glitch. This wasn't mere speculation. Engineers who design spacecraft for long-duration missions spend their careers trying to shield against this very problem. Cosmic ray strikes are a known and constant threat. While Voyager's systems are hardened, they are not invincible. After more than 3 decades in space, its components have been weathered by the constant sandblasting of radiation. The probability of such a direct, impactful hit on that specific instrument at that specific time was admittedly astronomically low. But the champions of this theory posed a critical question: what is more likely? A 1 in a billion chance of a random particle strike mimicking a signal, or the existence of a previously unknown interstellar object using a previously unknown method of communication to send a one-time message to a specific human probe for a previously unknown reason? Science operates on a principle of parsimony, often called Occam's razor. When faced with competing explanations, the simplest one, the one that requires the fewest new assumptions, is usually the correct one. A cosmic ray is a known phenomenon. Alien communication is not. For many, the choice was clear. The ghost in the machine was preferable to the ghost in the void. Yet even if you could set aside the local environment and the threat of cosmic rays, you would run headfirst into the most unforgiving barrier of all, the tyranny of distance and the fallibility of our own knowledge. The entire hypothesis of a connection hinges on a moment of celestial alignment. It requires that in October 2012, Voyager 1 and 3, Atlas, were in the right place at the right time, positioned for this fleeting, whisper-thin interaction to occur. But were they? How precisely can we actually know where 3I, Atlas, was 7 years before we ever saw it? This is the daunting challenge of trajectory reconstruction. When astronomers discovered 3I, Atlas, in 2019, it was a faint smudge of light. They observed it for a few precious months as it fell toward our Sunday. From that short arc of observed movement, they had to build a model, a mathematical simulation of its entire journey through the galaxy. They had to account for the gravitational pull of our sun of Jupiter of Saturn. Then they had to rewind the clock, running this simulation backward across 7 years and nearly 600 billion kilometers of space. This is a feat of staggering computational power. But it is not perfect. Every measurement has an error bar, a tiny sliver of uncertainty. The object's initial velocity, there's an error bar. Its precise direction of travel, there's an error bar. The subtle gravitational nudges from every star it passed 1 million years ago, we can only estimate. Each of these tiny uncertainties, when projected backward over such an immense distance and time, grows and magnifies. A microscopic error in the initial angle becomes a titanic uncertainty in its final position. It's like trying to trace the path of a rifle bullet back to the rifle that fired it years later, having only seen it glance off a wall in the final moments of its flight, all while a shifting wind was blowing. The final location is not a single point in space. It is a vast, blurry cloud of probability, a region billions of kilometers wide where the object might have been. The initial analysis that placed 3I, Atlas, in that perfect alignment with Voyager had selected the most probable path within that cloud, but other paths, only slightly less probable, were also possible. Paths that would have placed it millions of kilometers away from Voyager, making any direct communication utterly impossible. The celestial alignment, the very bedrock of the entire theory, was not a certainty. It was a possibility, perhaps even a probability, but it was built on a foundation of shifting sand. The supposed X marks the spot on the cosmic map was in reality a smudge of chalk 1 million miles wide. And this brought the entire inquiry to the final, most fundamental challenge: the nature of the signal itself. If this was a deliberate act of communication, it was a bizarre one. Throughout our decades of searching for extraterrestrial intelligence, we have operated on a core assumption that any intelligent species trying to make contact would want to make their signal obvious. They would use a channel that is quiet, like a specific radio frequency. They would encode their message in a way that is unmistakably artificial, using prime numbers, mathematical constants, or other patterns that nature does not produce. They would make it clear they are saying, "We are here." The Voyager anomaly was the exact opposite of this. It was not a clean radio signal beamed from the object. It was a messy, complex disturbance in the charged particles of spacetimes around times our probe. It was not encoded with the pristine language of mathematics, but was instead a chaotic burst of energy that required intense interpretation to be seen as anything other than noise. Why would a superior intelligence choose such an ambiguous, inefficient, and easily dismissed method of communication? Why whisper in a hurricane when you have the ability to shout in a library? It would be like trying to communicate with an undiscovered tribe in a dense jungle, not by broadcasting a clear sound, but by subtly rustling the leaves on a single tree and hoping someone notices and correctly interprets the pattern. The argument from the skeptics was that we weren't decoding a message, we were creating one. We were so desperate to find a pattern in the noise, a sign of intelligence in the cosmic static, that we had fallen prey to a form of cosmic pareidolia, seeing a face in the clouds, a signal in the randomness. The data spike was a Rorschach test for our own hopes and fears about our place in the universe, and we had chosen to see a greeting card from the stars. This is the crucible of the scientific method. It is a relentless and sometimes heartbreaking process of elimination. Every extraordinary claim is placed on a metaphorical anvil, and the hammers of skepticism begin to fall. One by one, the conventional explanations are brought to bear: the hammer of plasma physics, the hammer of cosmic ray interference, the hammer of orbital mechanics, the hammer of probability. The theory must withstand every single blow. If even one of these conventional explanations can account for the phenomenon, it becomes the default, the accepted truth, until more powerful evidence comes along. This isn't a sign of closed-mindedness. It is the opposite. It is the ultimate form of intellectual discipline, a firewall designed to protect us from our own profound capacity for self-deception. It is a testament to the respect scientists have for the universe. To claim we have found intelligence beyond Earth is to rewrite our entire understanding of existence. A discovery of that scale cannot be built on a maybe. It cannot be founded on a single uncorroborated data point from a 3-5-year-old probe aligned with the ghost of an object we no longer can see in a way that could be explained by a dozen different forms of cosmic weather. The scaffolding of skepticism grew higher and stronger, casting a long, cold shadow over the tantalizing possibility of contact. The narrative of a deliberate message was beginning to buckle under the immense weight of simpler, more terrestrial explanations. The case, for all intents and purposes, appeared to be closed, the anomaly refiled from potential signal to unusual but likely natural event. And for many in the scientific community, that is where the story ended. A fascinating puzzle, a wonderful what-if, but ultimately a dead end. The verdict was in a mistrial of cosmic proportions. The universe, it seemed, remained as silent and indifferent as ever. But science is never truly about closing a door and locking it forever. It is about checking, rechecking, and then checking again, always leaving a small opening for new evidence to slip through. And in a quiet corner of a data analysis lab, a small team unwilling to let go of the mystery decided to check the raw data one last time. Not the energy spike itself, but the background noise, the faint, almost imperceptible static from the moments just before and just after the event. What they were looking for was something no one else had thought to seek, a pattern not in the shout but in the silence that surrounded it. A detail so subtle it was hidden in plain sight, a characteristic that the chaotic violence of a cosmic ray or the brute force of a plasma wave simply could not explain. And so we stand at a precipice, staring into an abyss of possibility. We followed the breadcrumbs connecting a lonely probe's cryptic data with the silent passage of a visitor from another star system. The patterns seem to align, the timing appears impossibly precise, and a question at once terrifying and exhilarating hangs in the void. Did we, for a fleeting moment in 2012, overhear a conversation not meant for us? It is a story that ignites the deepest parts of our imagination, a narrative so powerful it feels as though it must times be true. But now we must step back from the edge. We must enter the cold, quiet, and unforgiving courtroom of science, where beautiful ideas are placed on the scales against the immense weight of evidence. Here, intuition and feeling are inadmissible. Here, correlation is relentlessly cross-examined to prove it is not mere coincidence. The burden of proof is absolute for an extraordinary claim. Perhaps the most extraordinary claim in human history demands a foundation of extraordinary, unassailable proof. The scientific endeavor compels us to dismantle the story piece by piece to see if its architecture can withstand the hurricane of scrutiny. We must begin with the first cry from the darkness, the strange behavior of Voyager 1. The probe, our steadfast emissary to the interstellar ocean, had become a ghost in its own machine. Its data stream for decades, a reliable rhythmic pulse from the abyss, suddenly faltered, speaking in a language its creators did not recognize. The idea of an external influence, a directed signal from 3i, Atlas, is an elegant and captivating solution. Yet there is another suspect, one far closer to home, hiding within the very heart of Voyager itself. You must remember, this is not a new machine. It is an artifact, a pioneer that has endured the unendurable. For more than 3 decades, by 2012, it had been flying through a shooting gallery pelted by high-energy cosmic rays, bathed in the charged particles of solar winds, and subjected to the relentless cold of deep space. Its electronic nervous system, a marvel of 1,970 seconds, engineering has been aging under conditions of unimaginable hostility. Within its intricate wiring lies the Attitude and Articulation Control Subsystem, the AACS. This is Voyager's brainstem, the system responsible for keeping its antenna pointed perfectly toward a tiny blue dot 4 light days away Earth. The anomalous data that so resembled a structured signal originated here. Engineers on the ground poring over diagnostic readouts found that the AACS had inexplicably begun routing its telemetry through a defunct, long-abandoned computer module on board. It was as if a part of the probe's mind, dormant for decades, had suddenly inexplicably awakened. The data wasn't a message, it was gibberish. It was the garbled, corrupted output from a dead memory sector, a phantom echo in the circuitry. The probe wasn't receiving a signal from 3i Atlas. It was talking to itself in its sleep. What could cause such a specific bizarre failure? The culprit is likely a single hypervelocity particle, a cosmic ray forged in the heart of a supernova millions of years ago that ended its journey by striking a single transistor, Voyager's memory. This event, known as a single event upset, can flip a bit of computer code, changing a 0 to a 1 or a 1 to a 0. It's a microscopic typo with potentially macroscopic consequences. A single flipped bit could have been all it took to reroute the AACS telemetry, creating a cascade of errors that from billions of kilometers away looked like something far more profound than a simple digital hiccup. The signal we strained to decipher may have been nothing more than the technological equivalent of a stroke, a momentary confusion in the mind of our oldest, most distant explorer. It is a less romantic explanation, to be sure. It replaces a cosmic dialogue with a mundane hardware fault, but it is an explanation grounded in the harsh realities of space travel, a reality Voyager's own engineers have seen time and time again. But what of the other anomaly, the sudden orientation shift and energy reading? Surely a single flipped bit couldn't account for the probe being physically jostled. This too, science finds, has a powerful natural explanation, one that has nothing to do with a directed energy beam. We imagine interstellar space as a perfect tranquil vacuum, but this is a profound misunderstanding of the environment Voyager now inhabits. It is a turbulent, dynamic place, a thin soup of charged particles and tangled magnetic fields, the breath of the galaxy itself. Voyager is traversing the heliosheath, a chaotic frontier where the solar wind from our own sun slams into the interstellar medium. Here, magnetic field lines from different sources can twist, break, and violently reconnect. This phenomenon, a magnetic reconnection event, is like a cosmic short circuit. It releases tremendous bursts of energy, accelerating particles to near light speed and creating powerful plasma waves that ripple through the region. Voyager in its journey could have flown directly through such a tempest. The sudden spike in energy wouldn't be a communication beam. It would be the probe's instruments registering the shockwave of this magnetic explosion. The minute shift in its orientation wouldn't be a push from a focused beam, but a nudge from a powerful gust of magnetized plasma. These events are known to happen. They are a fundamental process of plasma physics observed in Earth's magnetosphere and around distant stars. Placing Voyager in the path of one isn't an extraordinary leap. It is an entirely predictable consequence of its location. The interstellar medium, it seems, is perfectly capable of mimicking the very effects we so desperately wanted to attribute to another intelligence. With the Voyager anomalies now anchored to plausible, if less thrilling, natural phenomena, the entire hypothesis shifts its weight to the other side of the equation, 3I Atlas. The object itself remains the heart of the mystery. Its trajectory, its composition, its timing, all of it felt too perfect. Let us re-examine its path. The orbital calculations that placed it so tantalizingly close to Voyager in 2012 were based on a limited set of observations as it departed our solar system. But tracing an object's path backward through time, especially an object under the influence of the sun's immense gravity and the subtle nudges of the planets, is an exercise fraught with compounding uncertainty. The smallest error in measuring its velocity or position expands dramatically the further back in time you try to project. While the models showed a close approach, that term is cosmic in scale. The corridors of their potential paths might have intersected, but the error bars, the zones of uncertainty around both Voyager and 3I, Atlas, were colossal, spanning millions of kilometers. They were in the same celestial neighborhood, certainly, but they were not guaranteed to have been on the same city block. To assume a pinpoint accurate rendezvous stretches the data beyond its breaking point. Furthermore, the object's peculiar acceleration, its deviation from a purely gravitational path, was one of the key pieces of evidence for proponents of artificiality. It was moving as if under its own power, but we have seen this before. The interstellar comet Oumuamua exhibited a similar non-gravitational push, a behavior that planetary scientists now widely attribute to outgassing. As the object is warmed by the sun, hidden pockets of volatile ices like nitrogen or carbon monoxide can turn directly into gas, erupting in jets from the surface. These jets, even if they are too faint and diffuse to be seen by our telescopes, act like miniature rocket thrusters, gently altering the object's course. 3I, Atlas, was observed on its way out of the solar system after its closest approach to the Sunday. It would have already been heated, its surface activity potentially already underway but too faint to detect. The strange glow, the unusual spectral signature that defied easy classification, this too could be a consequence of its long journey. For untold eons, 3I, Atlas was adrift in the interstellar void, bombarded by the same cosmic rays that threatened Voyager's electronics. This relentless high-energy radiation can fundamentally alter the chemistry of a celestial body's surface, a process called space weathering. It can break down common molecules, bake simple organic compounds into complex dark reddish gunk, and create a chemical crust unlike anything we have ever seen on the asteroids and comets born and raised within our own solar system. Its strange color might not be the hull of a ship, but the scar tissue of a million-year voyage. What we interpreted as alien and artificial could simply be the face of something very, very old. Finally, we arrive at the most crucial test in all of science corroboration. If a momentous event truly occurred, an alien artifact hailing our most distant probe, it should not have been a silent, isolated affair. The universe is filled with our listening posts. The very act of sending a directed energy beam powerful enough to affect Voyager 1, even from a relatively close distance, would have been an act of immense energy expenditure. Such a signal would not have been a perfect narrow pencil of light. It would have scattered. It would have produced side lobes, echoes, reflections. And yet, in the terabytes of data streaming from our most powerful radio observatories, like the Very Large Array or the Green Bank Telescope, which were implicitly watching that sector of the sky, there is nothing. Absolute profound silence. There are no corroborating whispers, no phantom echoes picked up by more sensitive ears. And what of our other distant probes, New Horizons, was already on its way to Pluto, a silent witness in another part of the sky? The Pioneer probes, though largely defunct, were still being tracked. None of them registered a thing. The event, if it happened, left no other footprints in the snow. It exists only in the corrupted data of a single aging machine, and in the tantalizingly uncertain trajectory of a passing rock. This lack of independent verification is perhaps the most damning piece of evidence against the hypothesis. Science is a collaborative process, a consensus built from multiple independent lines of inquiry. Here there is only one line and it leads to a dead end. So where does this leave us? We are left with two competing narratives. One is a breathtaking story of first contact, a tale of impossible alignments and cosmic whispers, a story that requires us to accept a chain of improbable, unverified events. It requires us to believe in a technology we cannot comprehend, a motive we cannot fathom, and a signal that was detected by only the one instrument least equipped to do so, while leaving no other trace of its existence. The other narrative is a mosaic of separate, understood, and entirely natural phenomena. A hardware glitch on an old probe caused by predictable radiation damage, a physical nudge from a well-documented type of plasma event in deep space, the passage of a strange but likely natural object whose oddities can be explained by outgassing and extreme space weathering, a temporal and spatial alignment that, when examined with the proper understanding of orbital uncertainties, is far less perfect than it first appeared. Occam's razor, the principle that the simplest explanation is usually the correct one, cuts deep here, not because it is less interesting, but because it requires fewer new assumptions. It builds upon the physics we already know, rather than demanding we invent new ones. The overwhelming scientific consensus, therefore, has been forced to a conclusion. It is a conclusion reached not with triumphant certainty, but with a quiet, considered solemnity. Based on the full weight of the evidence available to us today, no verifiable communication occurred between 3I, Atlas, and Voyager 1. The anomalies, when placed under the harsh light of scientific rigor, resolve themselves into a series of unfortunate but ultimately understandable coincidences. The ghost in the machine was not an alien intelligence. It was most likely just a ghost, but this conclusion does not close the book. It simply marks the end of a chapter. The dismissal of one extraordinary hypothesis does not diminish the genuine mystery that both Voyager 1 and 3I, Atlas, represent. Voyager's journey continues a testament to our own tenacity, pushing ever deeper into a realm we are only just beginning to comprehend. Its occasional glitches are not failures, but stories etched into its very being, reminders of the unforgiving cosmos it calls home. And 3I, Atlas, it is gone now, receding from us at an incredible speed, never to return to our solar system. While the consensus points toward a natural origin, lingering questions persist. Its trajectory and composition were and remain highly unusual. It is an outlier, a specimen from a category of objects we have only just started to discover. It has shown us that the galaxy is filled with nomads, that the space between stars is not empty but is instead a highway for worlds torn from their birthplaces. Perhaps 3I, Atlas, was not a messenger, but it was a message nonetheless. A message that the universe is larger, more diverse, and infinitely stranger than we have ever allowed ourselves to imagine. The story of a potential conversation may have ended in a verdict of silence, but the feeling it inspired, that sense of profound, spine-tingling wonder, remains. It forced us to look at our most distant creation and a passing stranger and ask the most fundamental question of all, and the search for an answer to that question that has only just begun. And so we are left here adrift in the silent gulf between a tantalizing possibility and the unyielding certainty of the unknown. We find ourselves standing at the edge of a cosmic mystery without a conclusive answer, without the satisfaction of a final, unambiguous truth delivered from the void. The data streams from that extraordinary alignment in 2012 have been dissected, analyzed, and modeled by some of the most brilliant minds on our planet. They have been held up to the light of skepticism, and bathed in the glow of hopeful imagination. Yet, after all the processing, after all the debate, the ghost in the machine remains just that, a ghost. A phantom signal, an echo of intent, or perhaps nothing more than a spectacular illusion born from the chaotic interplay of plasma waves and ancient dying electronics. There is no definitive proof, no smoking gun to brandish and declare that humanity's most distant emissary, Voyager 1, was hailed by a traveller from another star. The formal conclusion, the one that will be entered into the austere ledgers of scientific record, will state that the phenomenon remains unexplained, a statistical anomaly of profound improbability, but an anomaly nonetheless. But to leave the story there would be to miss the entire point. It would be like finding a single indecipherable page from a lost library and lamenting that it isn't the whole book, instead of marveling at the very existence of the page itself. The true legacy of the 3I Atlas encounter is not to be found in a simple yes or no. Its profound importance lies not in the answer we sought, but in the breathtaking scope of the questions it forced us to ask. The journey this single fleeting cosmic coincidence ignited has done more to reshape our understanding of our place in the galaxy than a dozen confirmed discoveries might have. It has been a catalyst, a shock to our collective imagination that has rippled outwards, transforming entire fields of study and fundamentally altering the way we look at the darkness between the stars. The question of communication, in the end, became a kind of celestial koan, a riddle whose true purpose was not to be solved, but to awaken the mind to a much deeper reality. It was a cosmic prompt that propelled us over a new threshold of cosmic awareness. Before this event, our conception of interstellar space, the vast ocean Voyager had just entered, was largely academic. We saw it as an immense, almost featureless emptiness, a passive void separating the vibrant islands of solar systems. It was the final sterile frontier, but the desperate need to understand the medium through which a signal from 3I, Atlas, might have travelled to Voyager 1 compelled us to look again to model that space with a fidelity we had never before attempted. We were forced to build a new picture, and what emerged was not a void but a place of unimaginable complexity and subtle, violent beauty. We discovered a dynamic, textured environment, a region teeming with the unseen. We learned to map the swirling currents of the interstellar magnetic field, the very same field that may have focused or distorted the plasma emissions we detected. We began to trace the ethereal filaments of ionized hydrogen that stretch for light years, ghosts of ancient nebulae that act as a kind of cosmic weather system. This isn't an empty room. It is an ocean filled with a faint but persistent mist of dust grains, forged in the hearts of stars that died billions of years ago. Each microscopic particle is a time capsule carrying the chemical signature of its long-dead parent. It is a realm shot through with a high-energy fury of cosmic rays, particles accelerated to nearly the speed of light by supernovae, half a galaxy away, a constant invisible rain of radiation that our heliosphere had protected us from, our entire existence. By trying to listen for a whisper between two distant objects, we were forced to finally characterize the howling background gale of the galaxy itself. The heliopause, the boundary Voyager crossed, is no longer seen as a simple wall. It is a shoreline, a turbulent and chaotic frontier, where the solar wind, the breath of our own star, finally dies in a great shockwave, surrendering to the relentless pressure of this interstellar medium. It is a place of foam and fury, of magnetic reconnections and roiling plasma, a far more violent and unpredictable border than we had ever conceived. Our quest for a signal taught us to appreciate the symphony of the silence, to understand that the space between stars is just as alive and complex as the stars themselves. It is a place with history, with geography, and with a character all its own. And what of the messengers? What of these interstellar wanderers, these fleeting visitors from other hearths? Before the discovery of Oumuamua, and later the more familiar Borisov, the idea of detecting an object from another solar system was pure theory. They were statistical certainties that we assumed were too small, too dark, and moving too fast to ever be seen. We were a lonely port of call that had never logged the arrival of a foreign ship. Now we are beginning to understand that the galaxy is not a collection of isolated islands, but a dynamic, interconnected archipelago. Countless trillions of objects like 3i, Atlas, are likely sailing the interstellar seas at any given moment. They are the galaxy's nomads, the great diaspora of planetary formation. They are the shrapnel from cataclysmic planetary collisions, the orphaned comets flung from their systems by gravitational skirmishes between giant worlds, perhaps even the pristine, untouched building blocks of planets that never were. Each one is a geological and chemical sample delivered directly from a distant, unknown star system, a message in a bottle carrying the secrets of its origin. The frantic effort to characterize 3i, Atlas, after its potential significance was realized, has permanently revolutionized our approach to planetary defense and astronomical observation. We developed new algorithms, new ways of linking observatories across the globe into a single rapid response network. We learned to look for the subtle telltales of an interstellar trajectory far earlier, to project orbits with greater precision, to preemptively search for the faintest glint of light against the darkness. We are no longer passive observers waiting for these objects to stumble into our laps. We are becoming active hunters scanning the celestial horizons, preparing to intercept and study these travelers with a new generation of technology. 3i, Atlas, whether it was a simple comet or something more, served as the ultimate fire drill. It exposed the gaps in our capabilities and galvanized a global community of scientists to fill them. Because of the questions it raised, the next time a visitor from beyond crosses our threshold, we will be ready. We will not be caught looking back at faint data years later. We will be looking forward with instruments poised to capture every possible photon, every wisp of gas, every clue to its nature and its home. This entire saga has also brought into sharp, poignant focus the staggering achievement and the profound loneliness of Voyager 1. For decades, it has been our silent sentinel, a testament to human ingenuity and persistence, drifting ever further into the great dark. It is a machine of the 1,970 seconds, powered by the faint warmth of decaying plutonium, its digital mind running on less computing power than a modern car key fob. It is by every measure a relic, yet it endures. It continues to speak to us across an expanse so vast that its whispers, traveling at the speed of light, take more than a day to reach us. It is the most remote, the most isolated object ever created by human hands. And for a brief electrifying moment, we entertained the possibility that it was not alone. The 2012 event transformed our perception of the probe. It ceased to be merely a scientific instrument and became something more, an icon of contact, a potential point of dialogue. It became our symbolic hand extended into the cosmos, waiting for another to grasp it. This newfound reverence for Voyager has infused the teams at the Jet Propulsion Laboratory with a renewed sense of purpose. They are not just maintaining a machine, they are tending to a legacy. They are the keepers of a sacred flame, using every ounce of their ingenuity to coax a few more years, a few more months, a few more precious bits of data from its aging systems. They perform a kind of technological necromancy, rewriting code for a 4 or 5-year-old computer from 4 billion kilometers away, rerouting power around failing circuits, fighting against the inexorable decay of time and the harshness of the interstellar environment. Every packet of data it sends back is a gift, a final postcard from the abyss. The story of 3i, Atlas, gave Voyager one last glorious chapter. It reminded us that this tiny, fragile craft is not just a collection of wires and sensors. It is the distilled essence of our own curiosity, our own courage, our own desperate need to reach out beyond the confines of our world and see what lies beyond the horizon. It is a piece of us forever sailing toward the stars. Ultimately, this is a story about that curiosity. It is about the unquenchable, sometimes irrational and deeply human fire that drives us to ask, what if? It is the same impulse that led our ancient ancestors to look up at the flickering points of light in the night sky and weave them into stories of gods and monsters. It is the same drive that propelled Galileo to turn his telescope towards Jupiter and shatter the celestial spheres, the same passion that inspired Einstein to reimagine the very fabric of space-time. Science at its core is not just about finding answers, it is about falling in love with the questions. It is about embracing uncertainty and having the courage to chase down the most audacious possibilities, even if they lead to a dead end. The hypothesis that 3I Atlas communicated with Voyager 1 was, and remains, an extraordinary claim. It stretches the boundaries of our known science. But to have ignored it, to have dismissed it as a mere glitch without a thorough investigation, would have been an act of profound intellectual cowardice. It would have been a betrayal of the very spirit of exploration that sent Voyager on its epic journey in the first place. Humanity's search for extraterrestrial intelligence is often painted as a search for radio signals for deliberate broadcasts from advanced civilizations. We scan the skies with our radio telescopes, listening for a structured call, a beacon in the electronic darkness. But the saga of 3I Atlas suggests a different, more subtle possibility. Perhaps the first signs of intelligence will not be a deliberate message shouted across the cosmos. Perhaps they will be quieter, more ambiguous. They might come as artifacts, as probes, as technological relics sailing silently through our system. Or they may come, as this event did, as a whisper on the solar wind, a pattern hidden in the noise, a moment of inexplicable order in the midst of cosmic chaos. It has taught us that we must be prepared to look for life, not just in the ways we expect to find it, but in all the ways we can possibly imagine. We must be willing to entertain the improbable, to investigate the anomalous, and to hold in our minds the dual possibilities of sublime coincidence and profound deliberate contact. And so, the search continues, now broader and deeper than ever before. We look ahead to a future where our watchtowers will be more powerful, our eyes sharper. The Vera C. Rubin Observatory will soon begin its decade-long survey of the southern sky, a digital movie of the cosmos that will undoubtedly detect not one or two, but dozens, perhaps hundreds of interstellar objects every year. The James Webb Space Telescope and its successors will have the power to analyze the chemical composition of their faint atmospheres, searching for the biosignatures of distant life-bearing worlds. Future missions are being designed not just to observe, but to intercept, to chase down these visitors and study them up close, to read the stories written on their ancient surfaces. The era of passive observation is ending. A new era of active interstellar archaeology is about to begin. We may never know for certain what happened in the deep dark of 2012. The truth of that moment may be lost forever to the silence, a secret shared only between an ancient wandering comet and our lonely outbound probe. Perhaps it was a conversation, perhaps it was a coincidence of such staggering improbability that it rivals the imagination. Or perhaps, and this may be the most beautiful possibility of all, it was the universe itself, reminding us that there are still wonders beyond our comprehension, that the cosmos is still filled with a deep and resonant magic. The question remains hanging in the star-dusted void, not as a source of frustration, but as a perpetual invitation, an invitation to keep listening, to keep searching, to keep looking up, and to stand in perpetual breathless awe of the magnificent unanswered symphony of it all.